Hey gang, it's Will from Test. I'm at the DARPA Robotics Challenge, and we have seen something brand new. Kevin Albert has built a bunch of pneumatic robots, and it's unlike anything we've ever really seen before. Kevin, can you tell me a little bit about how these work and why air-powered robots?
Yeah, so these are entirely fabric-based robots that are filled with air, and we use the air for structure and actuation. So this chamber is just air and fabric, and in here we do antagonistic bellows that make the chambers move back and forth just like your muscles.
Okay, explain. There's a lot of things I want to break down here, but let's start with antagonistic bellows. What exactly, like in a normal robot arm, you're talking about motors that push and pull, right?
Right.
Along a joint. What, the bellows are doing the same thing?
Yeah, so exactly. So as you can see, there's a bellows here that's kind of scrunched up, and there's one here that's expanded. If we change where we put the air, it'll move by expanding the other bellows and scrunching up the other one. This is similar to how our muscles will pull the arm and push out here, and then vice versa. When we extend our arm, we pull back here and push here. So it's just the same kind of activation. So this is different than traditional robots that have rigid links and joints and bearings and shafts and things, and everything revolves around rigid mechanical design. Everything here is soft, everything here is pliable. This is so you can touch it, you can feel it, you can be safe around it.
So when you deflate this, it just rolls up like any a balloon?
That's right. So when we travel with all of this stuff, what we do is we deflate it, we roll it up, you can put it in your sock drawer. We actually brought our entire exhibit here by deflating everything and throwing it in the back of an SUV.
That's really incredible, and it's something unlike anything that we've seen before. How much precision do you get in the control of the robots when you're talking about using pneumatic?
Yeah, so exactly, that's one of the big challenges of working with a softer machine is it's really hard to sense. And so we can actually get similar precision to some of the rigid machines, but it's really a question of sensing at that point. And most robots sense by having an encoder at their joint and then just assuming their arm is stiff. And that lets you know what your whole arm is and where your hand is. Problem is that that's not true, especially for our robots. But even in the robots you see in the DRC, their links bend, there's backlash in the joints, these things aren't sensed. So these robots have error when they manipulate things.
Meaning it thinks its hand is here in relation to the object it's trying to grab, but it's actually a couple of millimeters or inches off.
That's exactly right.
Okay.
And for us, because we're so flexible, it's even farther than that. So what we do is we put in a whole sensing system to our controlled that allow us to get sub-centimeter precision on our movement without having to rely on any assumptions about the robot being stiff or rigid. So we can get fairly precise movements, but we actually sense what the robot's doing globally along the whole arm.
So I mean, it seems like it's another completely different approach to robotics, right?
Absolutely, yeah. And it's one thing that's going to allow robots to free themselves from this thing that they're currently in where they're scared to touch anything. So if you look at the way all robots act, they only want to touch the piece that they're picking up. So if they were to pick up a pencil, it'd be very fine and precise, and they wouldn't touch the table the pencil's on. But if you look at how humans behave, we actually just slam our fingers against the table, use the table as our sensor, and then pick up that pencil. So we've now created a machine that has that natural sense of touch and can do that because they're safe and because they won't damage the table or the pencil.
One of the things that you have interesting to set up here is this arm demo that the arm basically just kind of flails around, but because it's soft, even if it whacks you in the side of the head, it doesn't hurt. It's kind of fun.
That's exactly right. And this is kind of the point, right? Because if we imagine robots to be in our homes or helping us in the future, you're going to want a robot that you don't have to worry about being around at all times. That's not something that will actually become sustainable if you have to walk around your robot or have a no-go zone where your robot's sitting.
So what are your applications for this? What are your potential applications for this? I mean, I don't think you're going to replace like industrial car building robots with inflatable arms, but it seems like there's a lot of other opportunities.
Well, absolutely there is, and I mentioned this stuff in your home, helping elderly, doing your dishes, doing your laundry, things like this will all become possibilities in the future. But in the near term, there's actually a whole bunch of great applications for this technology because it also is extremely strong. And so we can lift a lot of weight for how much the robot weighs. And so we can do tasks that are in the warehousing sector and in the agriculture sector to help move materials where most robots aren't strong enough to move them and still be mobile.
Are there opportunities in like exoskeletons to help enhance human strength as well?
So there actually is. That's not our company. There's a separate company that also came out of Other Lab that does orthotics, and this is basically active clothing. It uses similar technology, but it does it basically co-located with the body so that it can move your arm, it can protect you against impact, it can protect you against injury, and it can give you assistance so you don't have fatigue and tendonitis and things like that.
So for like a home robot, is your thought that you would have like a normal rigid robot body and then use inflatable arms and limbs to control? or do you think eventually we'll see completely inflatable robots?
I think you will see completely inflatable robots, and I think in the home, likely you'll have them on wheeled bases. We don't necessarily need to walk just because walking is only good for rough terrain, whereas rolling around flat ground works very well. But as far as arms and the system that's actually going to be manipulating the things in your home, you're really going to want something that's inherently safe and inherently able to touch your things without breaking them.
Big Hero 6, right?
That's exactly right. And that movie was inspired by technology that was originally developed in our lab.
Super cool. Thank you so much, Kevin. And we will have more of the DARPA Robotics Challenge. See you guys soon.